let's continue, ladies and gentlemen. So let me share the screen again. Can you hear me, ladies and gentlemen?
Sure.
Okay, mute your mic, please. Okay, so I was saying when you make xi the subject of the formula, then you're going to have, for example, this time around, I won't write all the xi's. I will just write the expression for x1. Okay, so for x1, we are going to have a negative a12 over a11 x2, then minus a13 x3 over a11, and so on up to minus a1n xn over a11, then plus b1 over a11, right? That's what we are going to have. And then I was saying, before the meeting ended, I was saying, from here we need to substitute the values that we are getting from x0. So where there is x2, we are going to substitute the value that we are getting from x0. We'll do the same there so that we get x1. We are going to do the same thing for x2 after making x2 the subject from the second equation, so that after doing this, we should be able to get the first approximation, which will be denoted by capital X to the power 1, like that, and it's going to contain x1 1, comma, x2 1, comma, and so on up to xn1 transpose, right? So that's how we use the Jacobi's method. It is very simple. All you need to do is to make xi the subject of the formula, and then you will use the initial approximation that you have been given. Okay. Now, something that you need to remember is that in each and every expression that we are getting for xi, we are having ii in the denominator. So, because of that, we need to make sure that aii is not equal to 0. Because if, for example, a11 is equal to 0, then you won't be able to find the value of x1, right? So in other words, when you write your system of equations, a11 x1, for example, and so on up to a1n x n equal to b1, you do the same here. You're going to have an1 x1 plus and so on up to ann xn equal to bn. Then you need to make sure that values here in the diagonal are not equal to 0. So these values in there should not be equal to 0. That's what this means. Okay, because if any of those is equal to 0, then as you make xi the subject to the formula, you are going to be dividing by 0, which will give you something which is undefined, right? So that's what we are going to do. Okay, so as you do this, for example, you'll be able to see that in there, maybe in the first expression x1, we'll denote this by xk, like that. So that here we use xk minus 1. Then, just a minute, let me get rid of that bar, okay? We are going to have xk minus 1 there. Then if you move on to the next value, you're going to have k minus 1 also, up to k minus 1 here, so that you start substituting values of k now. So k0 will be the initial approximation that you have been given. So after getting k1, you use that k1 to find k2. To find k3, you use k2, and so on. So as you do that, like I mentioned, you'll be able to generate this sequence xk from k equal to 0 to infinity. And then this should converge to the solution x that you're looking for. So you can do as many iterations as possible So what can help us to know where we are supposed to stop will be maybe the number of iterations that we have been taught to do in the question. Or we can use the L infinite norm. Okay, so you'll be able to see that as we look at the first example there under Jacobi's method, example 3.1.5. So before I move on to that example, any questions on what we have considered? Any questions, ladies and gentlemen, on what we have considered so far? Okay, good. Let me move on. Yeah, good. Let me move on to the next board now so that we look at example 3.1.5. So I won't be able to write everything. You have this same example in the notes. So I'll just try to explain the most important things that you need to remember. Okay, so you have been given this system, 10x1 minus x2 plus 2x3 is equal to 6. And then minus x1. Okay, someone is saying just repeat on how to use k. So k there is just representing the number of iterations that you'll be doing. Okay. I said that you will generate this sequence from k equal to 0 up to infinity. Of course, when k is equal to 0, you're going to get x naught, which is the initial approximation which has been given. You always please mute your mic. Somebody's mic is unmuted. Let me try to see who this person is. Boniface, I think this is the last time I'm warning you. If you don't want to mute your mic, I'll put you in the waiting room and you won't be able to join in. Please mute your mic. Boniface Simwanza. Okay, so X naught, like I mentioned, is the initial approximation. You will always be given that initial approximation. So you just use this to approximate X1. So you'll be able to say that to approximate or to get X1, you need to use X0 and so on, right? Is that okay? The person who asked this question. Now I need to wrap this so that I can write the system of equations that we are looking at. So I have minus x1 plus 11 x2 minus x3 plus 3 x4 is equal to 25. And then 2x1 minus x2 plus 10 x3 minus x4 is equal to negative 11. Then we have 3x2 minus x3 plus 8x4 is equal to 15, right? And then we have been given a stopping criterion in this case. And then it says we have to stop when the norm, this norm, xk minus xk minus 1, the L infinite norm of that is less than 10 to the power negative 3. Okay, so you need to be doing, or you need to be using this stopping criterion every after an iteration. Every after one iteration, you need to use this. And it says 10 to the power negative 3, right? Oh, let me get rid of this. Sorry, ladies and gentlemen. Yeah. So that's what we are going to do. So from here, I need to first look at those values in the diagonal. Are they equal to 0? If I have any value which is equal to 0, then I can't use the Jacobi's iterative method, right? So I'm able to see that here, the first term is non-zero, so that's okay. Here, it is non-zero, then the next value I have is 10, and lastly, I have 8. So since those are non-zero, then I can use Jacobi's method. So all I need to do is to make x1 the subject of the formula from this equation. Then I need to make x2 the subject of the formula from that second equation, x3 the subject of the formula again from the third equation, and lastly x4 the subject of the formula from the fourth equation. right? So let's do that on the next board. Okay, so somebody has asked a question. So let me see this question. Sorry for. Okay, I understand, it's okay. Let's move on. So using the first equation, I can make x1 the subject to the formula, and this one will just be equal to 1 over 10, then x2 minus 2x3 plus 6. Okay. Now, since we are doing k iterations, we don't know the value of k. We'll be able to tell by looking at the stopping criterion. So I have to write my equation in this form: x1k, then x2k minus 1, and x2k minus 1. I mean x3 k minus 1, like that, right? And then I'll do the same to the second equation. I'll make x2 the subject to the formula now. And if you do that, you'll be able to see that to give you 1 over 11, then x1 k minus 1, then plus x3 k minus 1, then minus 3 x4 k minus 1, plus the 25, right? Then x3k will do the same thing. I'll get 1 over 10, then from the, let me look at the equation again, from equation 3. Okay, good. So I have 1 over 10, yes. Then this will give you minus 2 x1 k minus 1, then plus x2 k minus 1, then plus x4 k minus 1, then minus 11, right? And lastly, the last equation will be given by this: x4k will be 1 over 8 minus 3x2k minus 1, then plus x3k minus 1, then plus 15, right? So that's what we are going to do. And then I'll be able to use the first or the initial approximation. So in this question, I've been given that actually I didn't write this when I was talking about or when I was writing this question. We have been given x naught, which will be equal to 0, 0, 0, 0 transpose. So this is the initial approximation that we have been given. You will always be given the initial approximation, and then you need to use that to find x1. So x naught has been given. So from here, let me do the first iteration. When k is equal to 1, then what will I have? I'm going to have x1, 1 equal to 1 over 10, x2, 0, right? Minus 2, x3, 0, plus 6. And then I can substitute the value of x2, 0, okay, and x3, 0. And you see that those are zeros. So this will just give you 1 over 10 times 6. Right? That's the value that we are going to get, because this is 0 and that is also 0. Okay? So we'll be able to see that this will just be equal to 0.6. So that's x1. So let me move on to the next board and do the same to this value here. Okay, x2, x3, and so on. Okay. So to get x2, 1, I'll be able to see that this will just be equal to, using the formula for x2, I'll get 1 over 11, x1, 0, then plus x3, 0, then minus 3, x4, 0, then plus 25. And then I'll be able to substitute the value of x1, 0, x3, 0. Okay, so someone is asking, how are they zeros? Remember, x0 is given by 0, 0, 0. I mentioned that this is the initial approximation that you have been given. Okay, so from here, this means x10 is 0, and then x20 is 0, x30 is 0, and lastly, x40 is 0. Yeah,
And
you
then,
can
sir,
see those corresponding components of this column vector. Is that okay, sir?
another question, sir.
Okay.
Yeah, on X1 on the previous board, is it not 0.5, the answer?
0.5.
Yes, because 1 minus 2 plus 6 will give us 5.
No, sir. You have to substitute the values of, let me take you to the previous board.
Yes.
Okay. Okay. So what is the value of x20? Use the initial approximation. Let me give you the initial approximation.
Okay. I get it.
Okay, good.
Yes.
You
yes.
get
Thank
now?
you.
Okay.
Yeah.
So using that, you'll be able to get 0.6. We'll just be substituting corresponding values of x20 and x30. So we'll be able to do the same here. You're welcome. Kindly mute your mic now. Let me continue from here. So we'll be able to substitute values of x10, x30, and x40. So you'll be able to see that this is just 0 plus 0 minus 3 times 0 plus 25. So this will just give you 25 over 11. So that's the value you're going to get. And this will be approximately equal to 2.2727. Okay. So again, here you follow the instructions given in the question. The question, if you look at your notes, it says with 4 decimal place rounding off. So that's why after the decimal point, I need to have 4 figures there because of the instructions given in the question. Okay. So I'll do the same to find x31. So x31 will be given by 1 over 10 negative 2x10, then plus x20, then plus x40 minus 11, right? And if I substitute those values of x10, x20, and x40, I should be able to get negative 11 over 10, which will just be negative 1.1. Okay, you keep it, and then you find x41. So x41 will be 1 over 8 times minus 3x20, then plus x30 plus 15, right? Again, you substitute values of x20 and x30, you'll see that it will just give you 15 over 8. Okay, 15 over 8, if you write it in decimal form, it will just be equal to 1.8750. Okay, so that after doing this, you'll be able to write the value of x1. So x1 will now be equal to what? Capital X1 there. So it will have those 4 components in there and then transpose. So it will just be 0.6. If you want, you can maintain the number of figures after the decimal point. Therefore, according to the question, so it will be that value, then 2.2727, then comma x31, you got negative 1.1000, and lastly 1.8750 transpose. So that will be our first approximation. So we don't know whether this is the solution, or how should I put it? Or maybe let me say, we don't know if we should end here. We need to use the stopping criterion that we have been given in the question. Okay, so I need now to compute this x1 minus x0 the L infinite norm of that divided by, I can see this other part is not appearing on the other screen. So let me move on to the next board so that I use the stopping criterion. So after getting the first approximation, I need to test whether the stopping criterion is allowing me to end there or not. Okay, so let's find x1 minus x0 infinity there over this other norm, x1 infinity. If I find that this value is less than 10 to the power negative 3, then I'll be able to conclude that the solution is just x1, right? If it is still greater than 10 to the power negative 3, then I need to do more iterations. Okay, so let's find the value of this. Okay, so we know what this means. Then it means we'll be finding the maximum over absolute value over, I'll start with x1. Okay, so x1 minus, the small x1 minus x naught, x small, the small letter x naught. I'm sure you understand what I mean there. Okay, so I'll be able to say this is the absolute value over 0.6 minus x naught we have been given is 0. Okay, comma. The next value will be small x1, which is 2.2727. Then minus the first approximation is 0. So you continue doing that up to the last value. So the last value will be 1.8750 minus 0, right? So you find the maximum of that. I've run out of space here. That's the reason why I'm unable to write those other remaining terms. So you say this divided by x1 infinity. Okay, so the L infinite norm of x1 will just be equal to what? You will just find the maximum of those values, absolute value over 0.6, which is just equal to 0.6, comma, 2.2727, and so on. You'll be taking absolute values. I haven't written absolute values here, but you know that since they are positive numbers, they'll just give you positive numbers. But if you want, you can still include them. Okay, up to the last value, which is 1.8750. Okay, the maximum of that. So if you look at the values you have in the numerator, you are subtracting 0 from those values. So it means you still get the same values. And then when you choose the maximum from those, you'll be able to see that the maximum is just 2.2727. And then in the denominator, the maximum again is 2.2727. If you divide this, you should be able to get 1. And you'll be able to see that since 1 is greater than 10 to the power negative 3, then you need to do more iterations. So you move on to the second iteration. Are we together so far, ladies and gentlemen?
Yes, sir, it's very clear.
Okay, thank you so much. So now I'll move to the second iteration when k is equal to 2. So I'll be able to get x1, 2 will now be equal to 1 over 10. The same formula I got for x1. Now I'll be using values of capital X1. I'm going to get this, then minus 2, x3, 1, plus 6. Okay, so this now will be equal to 1 over 10. I'm sure people will be able to see that. Yeah, I think it's visible. Okay, then x11, I've gotten this value already. x11, using this, I'm able to get, actually it's x21. It's a 2.2727. So I'll just substitute those values in this formula. So actually here it's x2, not x1. Sorry, I didn't want to wrap that part. Just wanted to wrap that. Okay, good. So I'll be able to substitute. So I'll have 2.2727, then minus 2 times x3, 1. x3 is negative 1.1, okay, and then plus 6. So you can now, if you want, you can even use your calculator there. You'll be able to see that the value will be 1.0473. Okay, you need to have 4 digits after the decimal point according to the instructions given in the question. That's what you need to do. And then I'm sure you'll be able to continue doing this up to x4, right? And then you should be able to show that. So let me move to the next board. So you should be able to see that capital X2 will be given by 1.0473, 1.7159, negative 0.8052, 0.8852 transpose. Okay, so after getting the second approximation, or after doing the second iteration, I need to test the stopping criterion that have been given in the question. Okay, so again, I will do the norm, the infinite norm. I mean the L infinite norm over x2 minus x1 divided by x2 infinite. Okay, so remember here we just need to find the maximum over, so x2 minus x1. So I'll start with the first value, 1.0473, right? Then minus small x11. Okay, small x11, but remember that we got 0.6. So you keep that value, you move on to the next value. So it will be 1.7159 minus the value which we got, and it's 2.2727. Okay, absolute value of that. I've run out of space here, so let me continue down there. Then the next value will be negative 0.8052, then minus small x31. Okay, so that's just 1 point, negative 1.1. That's what we got, absolute value of that. And lastly, we are going to get 0.8852, the small x4 are 2 minus small x4 1. And the value we got there was 1.8750. Okay, so find the maximum of that, then divided by maximum of the components of capital X2. So it will just be absolute value of 1. Okay, let me write it like this. So I'll take absolute values already, so I won't be writing absolute values. I'll just be writing positive numbers now. So that I save on time. So I have 0.73, 1.7159, I take the absolute value of negative 0.8052, I'll get 0.8052. And lastly, 0.8852. So I'll take the maximum of that. So in the numerator, if you use your calculator, you should be able to see that the maximum will be 0.9898, right? And then in the denominator, the maximum should be this value, 1.7159. If you evaluate this, it will be able to give you 0.5768. Okay, if this value is less than 10 to the power negative 3, then I'll be able to stop at k equal to 2. But I'm able to see that this is not the case. Actually, this value is greater than 10 to the power negative 3. So I need to do more iterations. Okay, so because of that, I need to do more iterations. So I'll leave that to you as an exercise. So try to do as many iterations as possible. And you should be able to see that you need to stop at the 10th iteration. Okay, so you end here. And you'll be able to see that x10 minus capital X9 over this, you'll be able to see that it will be less than 10 to the power negative 3. So you need to end at the 10th iteration. So that's the Jacobi method. Very simple, ladies and gentlemen. All you need to do is make xi the subject of the formula. You also make sure that aii is not equal to 0. So you'll be able to see these other values from the 3rd iteration up to the 10th iteration. You'll be able to see them in the notes. So you can just verify that those values are correct. Are we together, ladies and gentlemen? Any questions on what we have considered so far?
So clear up to this point.
Okay, thank you so much. So let's move on to the other method. So let me move to the next board. But I'm shocked to see that even this account has the 40 minutes limit. So I've been warned here that in the next 7 minutes or so, this meeting will end. So maybe what I can do is, let me end this meeting and then we start a new one so that we have 40 minutes to discuss the other method, the other iterative method. Is that okay, ladies and gentlemen?
Yes, sir.
Yes, sir.
Okay, sir.
Yes.
Okay, good. So let me end this meeting and then kindly rejoin so that we can